Back in the day, we didn't have pencils. We had to write with our blood. It was horrible. So appreciate that. We invented graphite. Yes?
I guess number 31 on the exercise set. 1.6.
1.6?
Yeah.
Oh, okay. All right. What will pretty much save your ass repeatedly is order operations, right? This is the one that says x to the 5th, x to the 3rd, that one?
Yeah.
So there's a lot of different ways to do this, but I always say if you follow order operations, it actually comes out being the easiest way to do it. What's the first thing to do order operations wise? Inside the parentheses. I love it. So how many total x's do we have in there? 8. Right, 5. 3 more. I add exponents when I multiply, right? This is just chains in a link. What are we doing so far? And I left off still a -2 out there, right? There's a couple of ways of looking at this, but how do I do something with a power raised to a power? What do I do with these? Multiply. I like it. Always, no matter what. So even if I had this, x to the m. I'm doing the right one here, right?
Yeah.
All right, beautiful. I hate it when I'm like halfway through. Like, that's not the right one. This is freaky looking, right? This is not hard. What would this be?
Mn.
Yeah, x to the mn. Because what do you do with powers when you have a power raised to another power? You multiply the powers, no matter what. How are we doing so far? So math doesn't care that one of them is negative. It doesn't care if one of them is a fraction. It doesn't care if one of them is a decimal. It doesn't care. It's just, it doesn't care if they're letters. I get x to the negative 16, which is technically right, but there's one more thing you should do. Those 16 x's want to go down there. Lock it. What's the order operation saved me? I might look and go, holy shit, this is weird. I can just focus on the inside first and then kind of go from there. That's what order operations tells me to do. Alright. Good old order. Anything else from homework stuff? Yes?
Something dumb.
Beautiful.
How do you write 7,520 in scientific?
7,520?
Yeah.
Okay. That's not dumb. So where's the decimal? So to write this in scientific notation, where's the decimal currently? Where is it at the moment? The decimal? After the 0. That's why it's not showing up, because it's got nothing to...
Which number is this?
This is just a question from out of nowhere.
This is a question.
Hello. You can do that too. You can ask me, what if it was this? What if it was this? Beautiful question. I love it. So it's right here. So how many places do I have to move it? 1, 2, 3. Changing this into scientific notation, right? I love it. You like you're watching a movie. What's happening? And is it going to be positive or negative power? Positive, because this is a bigger number, right? So it'll be 7.52 times 10 to the 3rd. Is that cool?
Yes.
Okay.
And what is the decimal thing?
How do you mean?
Sometimes they're asking what's a scientific and what's a decimal.
You ready? This is scientific notation. This is
This is
decimal
decimal.
notation.
Yeah.
Even though there is an understood decimal, but just to differentiate it between, I don't want to say like number notation because these are still numbers. But this is what we officially call decimal notation. This is what we call scientific notation. It's a little bit wonky, but you know, we just don't want to call it scientific notation and not scientific notation. We want to give it a little word for itself. Is that decent? Okay, all right. I had one person from every row give me a signal that it was okay. Okay. Anything else from homework or just general? Yes?
So for number 28, for the same exercise section,
Yes.
would that be like, since it's 2 to the negative third, would you still put 1 over 2 to the third times?
You could. You totally could. There's two kind of main ways to do this problem. The first way is the way you're talking about. So look, we'll say, here's way one to do this, is to say that. What does it want to do? What do those 3 2's want to do? It's a negative power, so they want to flip. Become a 3. Is that cool? And then from there you can go a couple different ways, but I would probably do, you could do several, you could like reduce, can't you?
Yeah.
How many 2's can you kill?
1.
So how many are left down here?
2.
So you end up with 1 over 4. I like it. That is not the only way to do that. Is that cool?
Yeah.
Okay.
I did.
You did it wrong?
Yeah.
Shice. The other way to do this, it's good to have multiple ways to say shit, I think so. Scheisse is shit in German. Merde is shit in French. I can show you sign language on it. I know how to cuss in sign language, is awesome. What's the power here?
1.
1. What do you do when you have like bases and you multiply?
We add.
So you get 2 to the negative 3 plus 1 is 2 to the
Minus.
negative 2. Those 2 2's want to go down, so you get 1 over 2 squared, which is? Holy shit. Of course it's going to be the same. So math is not quite as black and white as people think. At this level there is an answer, but there's multiple ways to get to the answer. In later math, there isn't even a single answer. That's, there's multiple possible answers. So it's not even black and white, to be honest, at all. But right now it is. It's just multiple ways to get there. Is that decent? So as long as you show me what you're doing, I can reason out your logic and I can see if you are correctly applying math. There's more ways than that to do this problem, to be honest. But if you don't show me anything, I'm like, I don't even know what the hell you're doing. Okay, all right. Anything else from homework or just general? Yes?
Number 75.
In that same...
Yeah, the 1 point.
Okay. Oh, okay, beautiful. I love it. So tell me why the instructions say put this in scientific notation. And that sort of looks on first glance like it's already there. And you're like, oh cool, what a great problem, I'm done. Yeah, no, but what's wrong with it? Why is it not in scientific notation currently? The decimal.
Decimal's 0. It's not a real.
I like it. The number in front of the decimal is not a number between 1 and 9. Or another way to say it is the decimal's in the wrong place.
Yeah.
Where should the decimal be?
Behind the 4.
Behind the 4. Is that cool? We all cool with that? There's a couple different ways to do this problem. With math, it's kind of nice and bad that there are multiple ways to do problems. Because either it's nice, oh good, I don't understand that way, but I understand that way, thank God. Or, holy shit, there's too many ways to do this, I can't keep it in my head, oh shit. So try to make it a nice thing. We'll see what happens. Here's the way I do this. I do this, believe it or not, a less mathematical way. What does this want to do? That's a weird thing to say, but like what 2 times 10 to the third, it would want to move the decimal 3 places up, right? Make it bigger. So that'd be 2,000. Is that cool? So what does this want to do?
Make it bigger.
So take the decimal and move it that way, whatever it is to make it bigger, right? It's got to move how many times that way?
6.
6. So if I move the decimal here, now how many times does it have to move?
5.
All right, so I'm done. 4.1 times 10 to the 5th now. Bam, done. Thank you very much, right? All right, maybe that didn't make sense. Let me show you the other way to do this. The other way to do this is a little more, get your teeth into it a bit. Here's the first way to do it. The second way to do this is, how do I write this number? Let me just pull this aside. Just put that over there. There it is. There's the times 10 to the 6. That's nice for it. How do I write this in scientific notation? Will it have a negative power or a positive power? Looking at this number. The negative power because it's small, right? So it'll be, and where do I take that decimal? There. I love you guys all. You're doing good, Jeff. Right? I take, so it'll be 4.1 times 10 to the negative 1. Now what do I do with these? When I have like bases, I add the powers, right, when I multiply. So it'll be 4.1 times 10 to the negative 1 plus 6 is? Holy shit, same answer, yay. You guys see that? Very often there in math, there's a less mathematical way of doing a basic problem. This is kind of, I love this because it's like, oh shit, I got to move 6 places that way. I'm like, I'll carry you 1 step. Okay, I got to go 5 places still. I don't know, I don't know. That's the way I look at it. This is beautiful too because it's just scientific notation and then you just suck those 10s over. I know I don't use terminology you're used to because I tell you how I think of it. This is how I think of math. Right? Math doesn't change just because I think of it a different way. So you can think of it in a lot of different ways. All right, I like it. Maybe. I see some interesting looks on faces, but if you don't speak up, I have no idea how to interpret that. You okay?
Need more examples from this one, please.
Sure. That's an excellent question. What about this here? Let's do, no. Yeah. Is that in scientific notation currently?
No.
No. It's like some person didn't put the decimal in the right place. Damn it. So we got to clean up their mess. So let me try the first way again. The first way says, all right, how many places in which direction does this want to go? 7 that way, right? Where do I need to take the decimal though?
1 over to the left.
So am I adding to his work or taking away from this guy's work?
Adding.
Does that make sense? He has to go 7 that way. So if I took him, you got to go 7 that way? Ha ha. Now how many times does he have to go that way?
8.
8. Careful. I didn't go. See, that's why the first method is a little weird because you got to get used to. This wants to take it 7 that way. So if I take it back 1, now he's got to go 8 that way. Shit. Now again, if you don't like that method, you never have to do this ever in your whole life. Here's the other way to do this. The other way to do this is kind of pull that 7 10s over there. And now look at this. How do I make him become scientific notation? Will it be positive or negative exponent? Positive, because it's big. And I have to move it how many times? Once. So 1.12 times 10 to the positive 1. What do we do with powers? Stay with me now. 1.12 times 10 to the 8th. Same answer. Right? Either way you do it. Multiple ways of looking at it. Math doesn't care because the problem gets done. Is that cool? So this was an example where I went the same direction that the power wanted me to, and this is where I had to go the opposite direction the power wanted me to, and that's why it ended up going bigger. Maybe. Okay. Alright. I can't read some of you guys. Some of you are going to read all too. Like, shit, what the hell am I doing in there? Alright. Anything else from homework stuff? So let's do this. I want to actually, before we finish section 1.7, we sort of got into 1.7 yesterday with the Fibonacci sequence. Did anybody happen to look up anything with Fibonacci? If you didn't, I won't take it personal. You did?
Yeah,
what
artwork stuff.
Artwork stuff, kick-ass. Yeah, Fibonacci is big in art.
Yeah.
And the ideas of Fibonacci are big in art, where you can have things that build off of each other. That sounds like it could become a nice artistic thing.
So I like tattoos or that.
Oh, tattoos, cool.
Yeah,
Fibonacci tattoos. I might have to get one. I'll finally get a tattoo. Fibonacci tattoo. Yeah. Sorry. If there's no other questions, I want to get into a couple little things that I sort of realized I need to put in there that very often you guys don't see. First off, a real quick overview of the types of numbers. You guys should all know this already. Very quick. And then I'll talk specifically about one of these groups of numbers. So we start with natural numbers. Sometimes they're called counting numbers. So I like the word natural because these are the ones that came naturally to us. So you have a caveman walking around. He's going to count his rocks. You know, 1 rock, 2 rock, right? So that's the natural numbers. Naturally, because I got fingers. 1 finger, 2 finger. So that's the natural numbers. 1, 2, 3, 4, forever. Now, believe it or not, entire civilizations never had 0 in their number system. It had to be created. The idea of 0 and the symbol for 0 had to be created. So like the Babylonians, they discovered 0 right before the civilization fell. Alright, so when they wanted to tell people, oh yeah, I need 4,002 chairs, well, they didn't have a 0, so maybe they brought 42 chairs. And oh shit, I didn't know, you know. In fact, I teach Babylonian numbers in Math 120, and this would be like a Babylonian number. It's kind of neat. This is 10, 22. That would be the Babylonian number 22. And that's enough of that. I'll at least not do other civilizations numbers. So if I add in the idea of 0, I get whole numbers. And you got to love the name whole numbers because I'm adding in something that looks like a whole. I'm adding in 0. So if I add in 0, that's the whole number. Does this sound familiar? You guys have talked about this before? Or this is pretty simple, right? Okay. Now, so this is like if my caveman loses his rock. Now he has 0 rocks, and he's all sad. So he has to go borrow a rock. Like we have to borrow and get loans and shit. What do we have to use if I borrow something from somebody else? I owe them something. The idea of what? What do I have to add to this? If I owe you something, that would be denoted by what type of number? Negative. All right, cool. So that would be the integers. They add in the ideas of negative numbers. Stay with me. All right, so that's pretty good. That seems pretty nice. But if I make a number line, I normally when I make a number line, I do put those numbers on there, right? But what numbers am I not, that are on there that I'm not showing? For example, what's the next kind of level? What's in between? What's this number here? Decimals, fractions, right? Like that would be -1/2. So then the next level, and what's a fraction? What's another name for a fraction? Like 7/4. That is a what of 2 numbers? Ratio. Kick-ass. So these are called the rational numbers because it's made of ratios. Let me stop here for a second. Again, this might be old news to some of you guys. Again, when that happens, just enjoy it. That is nothing freaky yet. But here comes maybe some new news for you guys. So 7, any fraction obviously is rational. What about the number 3? Is that rational? Yeah, because it's over what? There you go. So every one of these is a rational number. In fact, notice every natural number is a whole number. Every whole number is an integer. Every integer is a rational number. They just keep adding some more ideas on top. You guys are kind of with me? What about 0.2? Is that rational? Probably because I put it in the list, but why? What is 0.2 as a fraction? 2/10. It's in the tenths place, right? That's 2/10. So any decimal that stops somewhere will be rational. Because what would this be? 1147921 over what? Oh yeah, dude. How many zeros will be on the bottom? This was 1 0 because it's one place in. So this is going to be how many zeros? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. You guys kind of with me? Every step out is another factor of 10 on the bottom. That's how it works, right? Are you guys with me? I guess some of you guys, again, are a little bored, but it's a good way to be. So like 0.002 would be what? 2 whats? Thousandths. Tenths, hundredths, thousands. 1, 2, 3, 1, 2, 3 zeros. Kick ass. Okay. Alright. So the freaky thing is, let me go to irrationals and then show you how this is not quite complete yet. Irrationals are the weird-ass things like pi. You guys know pi, right? Pi. Where did pi come from? From the oven? No shit.
The Greeks.
All right. Well, there are a lot of civilizations. The Egyptians, the Greeks, they all had their own way of estimating it. But the Egyptians, especially, if you take any circle, stay with me now. If you take any circle and you measure the outside, and somebody know what that name is? It's not the perimeter; it's the circumference. I like it. And you divide it by its diameter, you always get the same number, no matter if it's this circle or if it's cut the earth in half and it's that circle. That's kind of bigger, right? No matter what, so that freaked the hell out of these old civilizations. They're like, what? This number must be magic. This number must be given to us by the gods, and then we gave it this symbol, because it's a freaky ass number, right? So really, take the circumference divided by the diameter, and you get that number. And sure enough, some of you guys might remember C equals pi d is the formula for circumference, but that's kind of backwards. We got pi from this. I don't know if I lost anybody. Some of you guys tuned out. Please, this is kind of neat, actually. Right. So like, the Egyptians thought it was 22 divided by 7. If you do 22 divided by 7, you get 3.1 something. They got pretty close. Nowadays, we just let a computer do it for us. Computer. Spit it out to 5 million places. Okay. All right. Pi. Square root of 2. So we got to talk about the radicals here a little bit later. That's irrationals. Are you guys with me? Irrationals are the ones you cannot write as fractions. Irrational, not ratios. Right. Sweet. So there's still something that I'm missing up here, though. Pi is what? What's pi? 3.141596, blah, 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 forever, forever, forever. No pattern to it at all. Just this funky collection of numbers. You guys with me? Don't say pi is 3.14. That is not true. That is a decent estimate, but that's not what pi is. Pi goes forever. Right? There it is. So here's a little side note. This gets kind of neat. Does anybody know? Well, let's do it this. Let's do it this way. I like doing this one. 0.1111 forever. What's a better way to write that? Anybody know 0.1 with yeah, good. With a bar over top. That's a quick way to write. It just freaking is ones forever. Dude, don't make me write them all out. Just ones forever. That I can write as a fraction, believe it or not. I don't know if you guys believe me. I don't care if you believe me because I'm going to show you. You don't have to believe it. You can just see it. All right, now stay with me. It's kind of cool. There is one problem that you have to do this for. It's not a difficult thing. This is the power of algebra about to come down on you. So, watch this. It's kind of cool. What is this as a fraction? I don't know. When I don't know something in algebra, what do I call it? I don't know something in algebra, I give it a what? X. Kick ass. I love it. Right? Right? Yes? No? Some of you guys are like, I'd call it Y. Well, screw you. I'm going to call it X. But you can actually call it happy face. It doesn't matter. But I'm going to call it X. Stay with me. It's kind of cool. What sucks about that number? Why is it hard to wrap your brain around that number? Because it goes how far?
Forever.
Forever. So that forever part of it sucks. If I could just get rid of that forever part of it, I know that sounds like the opposite of romantic or I'll be with you forever. No, screw that part. But oh well. That's not what I'm talking about here. I'm talking about I want to wrap my head around that number, I gotta kill the forever part of it. It still sounds horrible, but oh. This is cool. This is cool. Let it be cool. What if I multiply both sides by 10? I get 10x there, right? When I multiply a decimal by 10, what happens to it? The decimal does what? Moves one place, because our number system is based on 10. So this becomes 1.1 forever. So again, so if I multiply 0.27, if I multiply that by 10, what does it become? 2.7. I multiply by 10 again, it becomes 27. Multiply by 10 again, it becomes 270. It just moves the decimal place. Division by 10 moves it back. That's why scientific notation works, for example, right? Just moving, moving, moving. Let me stop there for a second. You guys kind of with me? So again, just to show a few more ones. All I do is I take the decimal and move it once when I multiply by 10, so it becomes 1.1 forever. So what do I get when I subtract these? This way, 10x minus x is, what's 10x minus x? 9 x's. Kick ass. Don't say 10. The x's don't disappear. I got 10 x's, I take 1 now, I got 9 x's. And what happens if I subtract these? What happens to all these ones? They cancel. What's 1 minus 0? Now how do I solve this for x? What do I do to both sides? Divide by 9. Now, so what's this mean? What was x to begin with? X was the thing I didn't know, which was what this was as a fraction. So what did I just figure out? 1 divided by 9 is 0.11. If you did it in your calculator, 1 divided by 9 is 0.1 forever. Of course, it would stop at the end of its screen and go, dude, that's all I can show you. So what do you think? So if 1/9 is 0.1111, what's 2/9? 1/9 is 0.1111. 2/9 is point. Right? What's 3/9? And you guys know this. You guys know this. 1/3 as a decimal, most of you should know, is 0.333333. We just sort of proved it in like a building block kind of way. All right. I appreciate that most of you guys still seem to be with me. It's a little bit freaky of an idea, yes?
Can you do the first one, the 0.111 over again?
I can do a different one. Let's do a different one. And by the way, so what I'm saying here is the rationals are any decimal that has a pattern to it like that. Either a number repeats, or 2 number repeat, or 3, like 0.24, 24, 24, 24. We'll do that one. Let's figure out what that looks like as a fraction. So 0.242424. I want to know what that is as a fraction. So what's the first step? I don't know what the answer is, so I call it x. And the power of algebra just allows me to keep track of what the hell I'm doing. I don't know what it is, so I call it x. Now I can do something to both sides. Now, here I multiply by 10. Why? Move the decimal so that these would match up and cancel. Does somebody see something different here I got to do? If I move the decimal once, will this be the same? Will the repeating part? No. And the repeating part would then be 42. Oh shit, so I've got to move it how many times? Okay, cool. So I've got to multiply by what? 100. That would make this move over and it becomes 24.2424 forever. Do you guys see the general way to do? If I had 3, I would multiply by 1,000. It's crazy. So what do I get here? What's 100x minus x? 99x. 24 minus 0 is 24, and then these cancel. And then how do I solve for x? Divide by 99. Now what can I do with that fraction? You guys see something I can do with that? Let me talk about this too at the same time.
Divided by 3.
Beautiful. How can you anybody know how you can quickly tell if something's divisible by 3 and don't say, yeah, I do this. How can you do it in your head?
Is it if you add the numbers together and they're divisible by 3?
Beautiful. So if I add the digits of any number together, and if the result is a multiple of 3, it's divisible by 3. If it's a multiple of 9, it's divisible by 9. Don't take that farther than that. If it's a multiple of 7, no, screw it. 3 and 9 have that property. So sure enough, 2 plus 4 is 6, divisible by 3. 9 and 9 is 18, divisible by 3. So 3 goes into both. 3 goes into 24, 99. So if you did 8 divided by 33 in your calculator, it would come out to be 0.242424. Yes, ma'am?
So is it if there's a pattern to what comes after the decimal point, then you can turn it into a fraction?
Exactly.
So,
using this process.
So does that make them rational numbers?
Totally.
Okay.
If you can take a number that's given to you, 7, and write it as a ratio of integers, where the bottom's not 0, right? Then it is a rational number. So 7 is rational because I can write it as 7 over 1. 0.24 forever is rational because I can write it as 8 divided by 33. guys with me? That's why they're called rational numbers, because they can be written as ratios of whole numbers, right? Or integers. Okay. Have you guys ever seen that before? Is it semi-cool, at least? A little tiny bit? Humor the math guy. All right. I love that shit. It's just so, it's relatively simple, but it's like, there's no way you would guess that that's what it is. There's no way you would guess that. Okay. So real quick, just to continue the idea I just had, and I think they have this in the book where, I don't remember, Scheisse. I don't remember where they have this. I think, oh, there it is, page 3. Yes.
I missed it. Why did the 100x become 99?
Oh, no. What did I do between these two? I subtracted this way. 100x minus that, and then I subtract the other side also.
Oh, yeah.
That's what makes it legal if I do both sides. Yeah. I like it. There's a lot kind of hidden in here, and I know we haven't officially talked about the solvent equations, but I'm hoping everybody kind of remembers you divide to kill that coefficient, right? There's a little bit of stuff, extra stuff in there. So we know how to figure out if something's divisible by 3 and 9. You add the digits. So is this divisible by 3? Sure.